Hello, COP3530. I hope wherever you're watching this, you're good, you're feeling healthy, feeling clean. Um, so this is the video for Project 3, outlining what our application does. Our application is a simple command prompt application, and it goes through a 1.6 million line CSV and parses through the information to find zip codes, and then we input those zip codes into a red-black tree and AVL tree, respectively, and then we sort them by population. And then using those two trees, we're able to find the zip codes of the greatest population and the zip codes of the lowest population. So we first compiled the program. So it's compiling, and it compiled without any warnings or errors, so that's a good sign. Then let me just run the program. So the program first starts by parsing, it tells you it's parsing through the CSV. And then after it parses through the CSV, it tells you how many lines it went through, and then how many zip codes it found in the CSV. And the CSV we're using is the 2010 census. I don't think the 2020 is out yet, so we were just stuck with the one from last decade. And then after it tells you how many zip codes it finds, it tells you the time it takes to build the AVL tree and the red-black tree. And then it gives you two options. It tells you to you either type 1 or 2 to give you the least populated zip codes, or you type 2 to find the most populated zip codes. I press 1, and it then asks you how many zip codes you want to display. Like 100, it's going to output 100 of the least populated zip codes. And apparently there's a zip code with a population of 0. I googled it, and apparently it's true. I don't know, kind of weird. But yeah, it goes from least to greatest until you hit the 100 node. And then it tells you how many times it takes to display the number of lines of zip codes for the red-black tree, which in this case it took about 0.38 seconds. And then it shows you the same list again for the AVL tree. But then it tells you how long it took for the AVL tree to find it, which also it took about 0.34. That's a little bit faster than the red-black tree. But the red-black tree's main advantage is the time it takes to first insert into the tree. As you can see, the AVL tree took 0.02 seconds, and the red-black tree took 0.01 seconds, so it was twice as fast. So if you're inserting a lot of data and you're not retrieving a lot, it looks like the red-black tree wins out. But if you're retrieving a lot of data, then AVL tree is winning. But let's run the program again. Whoops. Parts through the CSV. A project through the CSV is probably the longest it takes here because it has a parts through a bunch of lines. And then let's do decreasing order, and then let's just print out 15 zip codes. If I print out 15 zip codes, the time it takes for the red-black tree is 0.047-ish seconds, and then for the AVL tree it's 0.064. It looks like for small retrievals, it looks like the red-black tree wins out by a smidgen. So if you're doing a lot of inserting small retrievals, it looks like red-black tree wins. And then if you're doing a lot of retrievals, it looks like you want to go with the AVL tree. And yeah, it's basically the code. It it finds the most populated, least populated zip code, most populated and least populated zip codes, and yeah, that's basically it.